Alright, so in this lesson we're continuing our addition of rational expressions, and to do that we just want to remind ourselves about elementary school addition of fractions, where we didn't have like denominators like this problem here. Notice we have 15 and we have 12. Those aren't the same. We need to figure out what would make them the same. So what's the least common denominator that I can make between 15 and 12 looking at their factors? And if I multiply the 15 times 4, that would give me 60, and 12 also goes into 60 if I multiply it by 5. So, now that I figured that out, I want my common denominator then to be 60. So, I multiply the top and bottom of the left one by 4, the top and bottom of the right one by 5, and so this will turn out to be 4 times 7, so that can be rewritten as 28, plus 5 times 5 is 25. So because they both have the common denominator now, I just went ahead and wrote it once, and then just combined the tops on top of that 60. So to finish, all I have to do is add the tops, the 28 and the 25, and that should give me 53 over 60. So that's our quick little refresher from elementary school. Now we're going to see how that applies to rational expressions. So what we're looking at is denominators that are very close, but not quite the same as each other. What we notice is that we see 9, we see 27. So the first thing we should work through is, let's just look at the numbers. How do I make a 9 turn into a 27 or a factor of the both of them? Well, 9 does actually go into 27, so that's nice here. So I just have to multiply it by 3. So if I put times 3 here, top and bottom, I made my 27. Okay, so I can go ahead and write the 27 because I know that's going to be my like denominator. So now on the a's, we have a to the 8th. Well, I have to make this 4 turn into an 8. So what that means is I need to multiply I need 4 more a's over here, so I'm going to multiply the top and bottom of this one by a to the 4th. So now that I've done that, I know that I will have a total of 8 a's, so I can just write a to the 8 over here in my denominator answer, just to keep track of my common denominator. And then notice that I've got b to the 7 here. This one's only got 3, so that means it needs 4 more. So I go ahead and multiply by b to the 4th and b to the 4th on top. And then I can go ahead and put that in my answer that I have b to the 7th as my common denominator. So now what you can notice is that the first part gave me 3 times 4t, so I just multiply those together to get 12t. And then you take your plus sign and go ahead and put it over in the middle, and I have to combine what's left here, the 5s, a to the 4th, b to the 4th. Well, it doesn't actually multiply out very well, so I just write 5s, a to the 4th, b to the 4th. Okay, so now I've written it all over my common denominator here, and on the top I look for, is there any way I combine anything? There's nothing to combine. So because it's all over my common denominator, I'm done. I've combined my rational expressions. Another way of looking at the problem is that really the first fraction I created, I could rewrite to be 12t over 27, a to the 8th, b to the 7th, and then plus 5s, a to the 4th, b to the 4th, over 27, a to the 8th, b to the 7th. So you can see that I had common denominators before I wrote it all together at once. I just kind of skipped that step because I'm combining the tops anyway. Once you have the bottom the same, you really just slide the tops together. So that's why I don't write that usually. So check out this problem. What you'll notice is that the denominators are very similar, that they both have an x, and so our minds kind of just want to say, well, can I just make this to be a 4 or this one have a 7 somehow? But it doesn't work out that nicely. What I actually have to do is realize that this is a whole term. This is a whole actual number. This would be like if you had a 3 and a 5. Okay, well, the only thing you could do is if with 3 and 5 is you'd have to multiply this one by a 5 top and bottom and this one by a 3 top and bottom. So that's actually what we have to do with this particular problem. What I'm saying is this parentheses is a number. so we have to treat it like a number. And that means that I have to multiply the left fraction by x minus 7, top and bottom. And the right fraction needs a x plus 4, top and bottom. And once you do that, you can go ahead and distribute the top, and you can just write the bottom. So if I was to do that extra step here, this would turn into, if I distributed that, that would turn into 2x squared minus 14x. And then on bottom, I just leave the x minus 7 times x plus 4. Plus, distribute the top of the second one, and I get 3x squared plus 12x over x minus 7 times x plus 4. Now, the denominators are the same, so you really didn't have to write them as two fractions here. It's all over the same thing. So the tops can actually be on top with each other, and I need to combine the like terms. So I need to take the 2x squared and combine it with the 3x squared, and that should give me 5x squared. And I should add the negative 14 and the 12, that should give me negative 2x. And then I put it all back over x minus 7 and x plus 4. Now this is actually your answer, but you do want to go ahead and check to see if there's any factoring you can do on the top to just see if anything would cancel at the bottom. So you should recognize they both have an x in common, so I could rewrite it by pulling out an x and putting 5x minus 2. But then it doesn't really help me to simplify it all, and I believe the lab will take the blue answer I had just a second ago. But this is also a valid answer. Okay, so both these answers are correct. I don't think the lab makes a difference between the two. I wouldn't either. Alright, here we go. On this example, we've got 3 different denominators. Okay, and it's exactly like if you had a problem where you had 1/2 minus 1/3 minus 1/5. You would have to take and multiply all of these together. Well, this example is actually not quite as close as this one. It'd be more like this, where I've got 6 on the bottom. Because notice this one is squared. So it's actually the product of the 2 previous ones. So if you had this, you would have to multiply this one by 3 top and bottom, multiply this one by 2 top and bottom, and then they all have a denominator of 6, and then you would combine your like terms. Well, that's exactly the situation I have here, but with parentheses. Okay? This x squared minus 1 is actually x minus 1 times x plus 1, because we have the difference of squares. And so what that means is that this first fraction needs an x plus 1 to the top and the bottom. The second fraction needs an x minus 1 to the top and bottom. And now they all have the same denominator. So I can write it all over the same denominator of x minus 1 times x plus 1. And so I'll circle with color the first one and write it down here. I'm going to go ahead and distribute that. So that's going to turn into 4x squared minus 4x. Okay. Now in blue I'll do the second one. Now we have to be careful because there's a minus sign. So I'll put minus parentheses. Distribute the 2 to the x and to the negative 1, so it would be 2x minus 2. Now the reason again I put parentheses there is because there is a negative sign that's going to have to get distributed in a little bit. And finally in brown, we've got the 4 that just comes down minus 4. Okay. Now we do want to actually distribute that negative sign, and that will cause us to have 4x squared minus 4x minus 2x plus 2 minus 4, all over our denominator of x squared minus 1, or sorry, x not squared, minus 1 times x plus 1. And then we go ahead and simplify the top by combining our like terms, and we notice that we have negative 4x and negative 2x. That should give us negative 6x. And then we have a negative 4 and positive 2, and that should give us negative 2. So I should rewrite it to be 4x squared minus 6x minus 2 is what the top would be. And I'm going to go ahead and factor that just to see if I can actually factor it. I can pull out a 2, but by the way, again, this is still over x minus 1 times x plus 1. And again, I believe that the lab will accept that as your answer, but I can go further by pulling out a 2 and factoring the top. And if you notice, on the top here I did actually factor it, but it's not going to get us any common factors at the bottom to get anything to cancel. So what I have boxed here in the red is actually going to be your final answer. And here's one more example of adding when there's 3 fractions. And yes, I did actually say 3 fractions, even though the 6 is not written as a fraction, it really is. It's over a 1. So what I need to notice is that this 3r minus 1 needs another 3r minus 1 because this one has 2. So each one of them needs a 3r minus 1 squared. So to get that, this middle fraction needs to be multiplied by 3r minus 1 on the bottom and on the top. And this last fraction, the negative 6, needs it to the top and the bottom, a 3r minus 1 squared. Okay, so now they all have a common denominator of 3r minus 1 squared. So the first fraction still has just the 8. The second fraction, if I distribute, has plus 6r minus 2. And the third fraction, I don't get to distribute that negative 6, and be careful, it is a negative 6. I actually have to FOIL the 3r minus 1 squared first, because 3r minus 1 squared should be written twice and FOILed like that. And then there's a 6 out in front. So if I do the work up there, this would give me 9r squared minus 6r minus plus 1. And then that needs to be times by 6, and so you would distribute the 6 there, and it is a negative 6 still, so I'll go ahead and distribute that, and that should give us a negative 54r squared plus 36r minus 6. So I'll go ahead and write that over here, minus 54r squared plus 36r minus 6. So again, that whole red part came from distributing and FOILing that last part on the negative 6. So then I just combine my like terms on top, and nothing goes with the 54r, so I just write negative 54r squared. And then I've got 36r, and I've got another 6r, so that's going to give me 42r. And then I've got my negative 6, negative 2, and 8. So negative 6, negative 2, and 8 all need to combine, and that'll cancel out because it gives me negative 8, positive 8. And then that's all over 3r minus 1 squared. Okay? And so you could go ahead and check to see if something factors on the top, or you could at least reduce it, but nothing's going to cancel. So I could pull out a negative r or a positive r, it doesn't matter. And actually you could take some common factors, a number out also. So I could pull out a negative 6r, and that would leave me with 9r minus 7 on the top. So that would be a better factored form of the top, but again, it's not really necessary. I don't believe the lab will require you to have that. But this is the answer I had before I factored, and it will be just fine. If it does give you any grief, just go ahead and look for if it wants a more factored form. You can see that it has a negative 6 in common, 6r in common, and just factor that out. Okay. And now for our final, most difficult subtraction of rational expressions here. You'll notice that the two denominators are not the same, even though they have similar parts. And we don't want to multiply the whole trinomial on the left times the whole trinomial on the right. What we want to do here is we want to actually factor and see if we can have a common binomial factor. And so this can factor, and I went ahead and did the work here. You can see how I factored using the magic X at the bottom. just a quick reminder, when you've got two variables, like this one's got the y squared there, down when you do your magic x, you divide by the first variable, and then whatever the other variable is, you go ahead and put that as part of your answer here. So this would have been x minus 1, but because there's a y squared, you take and put whatever your variable, the second variable is, the y, in there in both those. So you can see that over here too, this one would have been x plus 6, but we got to put our 6y here. Okay? So this one would have been x minus 1, but we put x minus y. Okay? So I'm going to go ahead and erase the extra parts so we can continue on. Okay, so now our denominators, the old ones are really gone. Now we're just left with our factors. And what we want to recognize is they both have an x minus y. Okay? And what we need to recognize then is that this side has an x plus 2y, this one has an x plus 6y, which means the one on the right needs the x plus 2y. So what that means is I need to multiply that also to the top. And the second fraction needs the x plus 6y. So I need to multiply it on the bottom, and I need to multiply it on the top. So you can see how this is just kind of, it turns into a little bit of a lengthy problem, but it's not much different from the other ones we've been doing. So I'll just write it all as one big denominator, x minus y times x plus 6y times x plus 2y. And then you just go ahead and multiply and FOIL the top. Now be careful because there is a minus sign here we don't want to lose. So I'll go ahead and pause and FOIL. Well, I'll just work through it. So if I multiply, I'm going to get 5x squared. Multiply there, and that gives me 30xy. Then I take my negative y, and that's going to give me negative xy. And then negative y times 6y should give me negative 6y squared. So that's all from the first term. Now I'll do the second term in yellow. I should take and multiply. Now be careful here, I do have a negative sign that's coming down. I'm just going to leave it negative for now so we don't get confused. So we get 3x times x, which should give me 3x squared. And then 3x times 2y, which would give me 6xy. And then I should get my 2y times x, which should give me plus 2xy. And finally I get 2y times 2y, which should give me plus 4y squared. Now, the next step I should do is go through and change all the signs in the second one because they all need to be distributed by negative. So this negative sign is going to go to all of them. Okay? And without writing arrows to all of them and wasting space, I'm going to go ahead and just change the sign. So this is going to be, this one will be minus, this will be minus, this will be minus, and that'll be minus. Okay? So now I want to combine like terms. I'm going to erase a little bit so that I have some room. Okay. And so you can see that I've got 5x squareds and negative 3x squared, so that's going to give me 2x squared. And then I have my 30xy minus xy. It's going to give me 29, but then I've got 6 more of them over here, so now I'm up to 35, another 2 to get me to 37. Oh, I'm sorry, those are subtracting, going the wrong direction here. So I got 30 minus xy, so now I'm down to 29, minus another 6, so that's down to 23, and then lose another 2, so now I'm down to 21. Okay, so that gives me positive 21 xy. And finally, I need to combine my y squareds. So I got negative 6y squared, another negative 4y squared, so that should give me negative 10y squared. So then all we have to do is put that over top of our denominator, which was x minus y times x plus 6y, and then x plus 2y. And that'll be your final answer there.